Let us look at transformation of equations. We have looked at linear, quadratic, and cubic polynomials. Finding the roots becomes more and more difficult as the degree of the polynomial increases. So the problem of finding the roots of a polynomial f sub n of x can sometimes be simplified if we can somehow transform the polynomial into another polynomial g sub n of x whose roots have a known relation to those of f sub n of x. So we start off with f sub n of x, difficult to find the roots directly. So we transform f sub n of x to another equation g sub n of x whose roots are simplest to find and whose roots have some known relationship to the roots of f sub n of x. So instead of directly going, we go via this path. Thus, instead of attacking the roots directly, we attempt to construct a new polynomial whose roots are related in a simple and useful way to the original roots. Now, let the roots of f sub n of x equal to 0 be alpha 1, alpha 2, dot, 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 alpha sub n. Let the roots of g sub n of x equal to 0 be beta sub 1 to beta sub n. For I in 1, 2, 3, 4, dot, 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 n, relations between alpha sub I, that is 1 to n, and beta sub I are as follows, that we'll be looking at. Beta I is equal to minus alpha sub I. So this would be a reflection across y-axis. So we can say it is a reflection transformation. Beta sub I is equal to m times alpha sub I. So here's scaling transformation. Beta sub I is equal to 1 by alpha sub I. This is called a reciprocal transformation. Beta sub I is equal to alpha sub I plus or minus h. This is called a translation transformation. Of course, while learning these techniques, we shall use simpler examples to understand the underlying ideas. In these examples, the advantages of the techniques may not be immediately apparent because the roots of the original polynomial equations can be found by simpler methods. But later on, we will look at slightly more complicated uses. Now, before we proceed, an important note. Up to this point, we have written polynomials in descending powers of x. F sub n of x equal to a sub naught x to the power of n plus a sub 1 times x to the power of n minus 1, so on up to a sub n. Henceforth, a polynomial may also be written in ascending power of x. So 3x to the power of 4 plus 2x cubed plus 11x square plus 7x plus 4 may also be written as 4 plus 7x plus 11x square plus 2x cubed plus 3x to the power of 4. And as you can see, this is merely a different way of writing the same polynomial. It is not a transformation. Just the order in which we write is changed. So that was the introduction to transformation of equations. So in the next 4 sessions, we will look at all these different types of transformations: reflection, scaling, reciprocal, and translation transformations. That's it for now. Bye.